So we move a bit higher now. So what if we are not given a standard normal distribution? It is just a normal distribution. How do we do that? So in problems 8 to 10, assume that the random variable x is normally distributed with mean mu equals 50 and standard deviation sigma equals 7. Compute the following probabilities. Be sure to draw the normal curve with the area corresponding to the probabilities shaded. So number 8, P of x. Okay, so the probability that x is less or equal to 45. So x is just a normal random, a normal distribution, okay, or a random variable that follows a normal distribution. It is not standard normal. It is just a random variable that follows a normal distribution. If you remember what we saw under chapter 3, we looked at standardizing numbers, right, using the z-score. Okay, so what we can do is we can standardize this value. So by standardizing, what that means is we have a distribution where now the mean will be 0 and then the standard deviation will be 1 in that case. So if we want to standardize this value, we will be doing that with the motivation to be able to use the standard normal table to look for our probability or our area. So if I want to standardize that, the formula is z equals x minus the mu divided by the sigma. So the x is the value that we are working with. So x in this case is 45 minus 50 over 7. So our z value or the z-score is approximately negative 0.71. Now I made it to 2 decimal places because our standard normal table gives us the z-scores to 2 decimal places. Okay. So what that means is, what is already given to me, the probability of x is less than 45 is the same as the probability of z less or equal to negative 0.71. Because when we standardize 45 using the mean and the standard deviation given to us, the value is negative 0.71. So at this point, we can use the standard normal table to look for the area or the probability of the shaded region. So with the graph sketched, right, then the shaded region to the left of 45, because it is x is less or equal to 45. Now looking at the table, we look along the row for negative 0.7 and then along the column for 0.01, and that gives us 0.2389. So it means that the area, okay, or the probability of x being less or equal to 45 is 0.2389. So that is how you use the standard normal table. Okay, now I'm using this so that you know how it is done. But a way simpler approach that you can always rely on is using the normal CDF. So the normal CDF works perfectly well for any form of the normal distribution, whether you are dealing with the standard normal distribution or any ordinary normal distribution. So normal CDF. So looking at the shaded region, right, you start off with the smallest value, then the largest value, the mean, and then the standard deviation. The smallest value is negative infinity, okay? And the calculator way of writing it is negative 1e99. Negative 1e99, followed by this upper bound or the largest value in the interval, which is 45, then the mean of the distribution, 50, the standard deviation, 7. So our value becomes 0.2389 approximately. So the calculator value and then what the standard normal table gives us are approximately the same to 4 decimal places. All right. Then to the next one. So this time around, we have the probability of x greater than 35. So if it is greater than, it means you are looking for the area to the right of whatever number we have. Okay, so at this point, I'm just going to shade it and show you how to use the calculator syntax. But then you can practice how to use a standard normal table with what we have already discussed in the earlier questions and see if you'll be able to get a value close to what the calculator gives us. And I believe you should be able to. All right. Probability of x being greater than 35 by the calculator, that is normal CDF. The smallest value in this interval now is 35. And then the largest value is a very large positive value. So we say positive infinity. And that is 1E99. That is how we represent it on the calculator. And 50, and then 7. So 50 for the mean, 7 for the standard deviation. Therefore, this probability will be approximately 9.9838. Okay, so that is the result for question 9. All right. Now to question 10, still following the same preamble. So probability of x being greater than 40 and x being less than 65. So by sketch, you have the standard normal table. You have 40 on the left of 50, and then 65 on the right of 50. Then the shaded region is what we are looking for. So by the calculator syntax, which is always simpler to do, you have your normal CDF, the smallest value in the interval that you are looking for, okay, which is 40, then the largest value is 65, the mean is 50, then the standard deviation is 7. So that results to be 0.9074. Okay, so that is how you find the area, okay, for any normal distribution, the area in a particular region for any normal distribution. Okay. Now, what of finding the value x when you are given the area? Okay, so we look at problems 11 and 12. Now, in problems 11 and 12, assume that the random variable x is normally distributed with mean mu equals 50 and the standard deviation sigma equals 7. Find each indicated percentile for x. Okay, so I kind of did my sketch, right? Now, the first question says that 9th percentile. 9th percentile means 90%, right? So the first 9%, sorry, 9th percentile is 9%, the first 9%. So in other words, 9% to the left of x, right? So to the left of x, the area to the left of x is 9%, which is 0.09. Now we are being asked to find that x. Okay. So if we want to use the idea of the standard normal table, how do we use the standard normal table to get a value like this? 9% in a standard normal table will still be 9%. 9% in a standard normal distribution will still be 9% in any normal distribution, right? So if we can find the z-score in the standard normal distribution, we can use that z-score to get our x. Okay, so that is if you don't use the calculator syntax. How do you do that? So we want to first find the z-score when the area to its left is 0.09. An example like that we've seen before. So we look in the table and see where the area 0.09 falls, okay, or a number close to that. And the closest number to that is 0.0901. And that corresponds with the z-score of negative 1.34. So z will be negative 1.34. But then remember the equation or the formula z equals x minus mu over sigma, right? We can rewrite that formula where we make x the subject. Then x becomes x equals z times sigma plus mu. Okay, so there's some little algebra there. So what we realize is that for everything in the equation on the right, we have information on all of them so far. So we plug them in to be able to find x. So minus 1.34, which is for z, 7 for the sigma, and then 50 for the mu. The result of that will be x equals 40.62. So the x, which is the 9th percentile, right, is 40.62. Okay, using the calculator syntax as usual is straightforward, and that will be the inv norm, then area to the left is 0.09, the mean is 50, the standard deviation is 7, and that will approximately be 40.61. So you realize that the calculator result and then the standard normal table result will be a little bit off, but like approximately they are the same. Okay. So that is for question 11. Then the very last question in this section, right, it says 81st percentile. So we want to find the x value that occupies the 81st percentile. So what that means is that we are told the area to the left of it, which is 0.81 or 81%, and then we want to find the x that occupies that position. So at this point, I just want to use the calculator syntax to get that. You can try how to use the standard normal table to get the result. All right. So inv norm, you have the area, which is 0.81, area to the left, and then the mean is 50, and then the standard deviation is 7. So that will be approximately equal to 56.15. So that gives you the 81st percentile, or the number for which 81% are either less or equal to, or 19% are greater than. Yeah. All right. Thank you. If you have any question, you want to send me an email or create a thread in the forum on Blackboard, or you can come online during my office hour, which is the regular class time. Okay, you can connect through WebEx. Thank you.